In this lesson, we will take an introductory look at probability. As we progress through the module, we will build on today's lesson by examining additional concepts and more advanced strategies. To begin, probability is a quantity that measures the likelihood that some event will occur. So when we speak about the probability of an event, we are trying to assign a number to the likelihood that the event will occur. The probability of any event ranges from 0 to 1. The greater the probability, the more likely the event will occur. If the probability of an event is 0, then that event will not occur. Conversely, if the probability of an event is 1, then that event will definitely occur. So, for example, let's say we have a box that contains 3 red balls. If one ball is selected at random from the box, we can examine various probabilities. For example, the probability that the selected ball is green is equal to 0, since it would be impossible to draw a green ball from the box. Conversely, the probability that the selected ball is red is equal to 1, since we can be certain that the selected ball would be red. Now, when dealing with situations where there are countable outcomes, we can define the probability of an event as follows. It says that if we have a scenario or experiment where each outcome is equally likely to occur, then the probability that some event will occur is equal to the total number of outcomes where that event occurs divided by the total number of possible outcomes. Let's look at an example. Let's say we have a box containing 6 red balls and 2 green balls, and we randomly select one ball from the box. What is the probability that the selected ball is green? To answer this, we will apply the probability formula. Now, when we apply this formula, it's a good idea to calculate the denominator first. Doing so will often help us gain some insight into the question. So we'll begin by determining the total number of possible outcomes. Well, since there are 8 balls in total, there are 8 equally likely outcomes when a ball is randomly selected. Next, we'll examine the numerator. Now, we already know that our experiment has 8 possible outcomes. We now want to know how many of those 8 outcomes are such that a green ball is selected. Since 2 of the 8 balls are green, there are 2 possible outcomes where a green ball can be selected. Now, when we simplify 2/8, we get 1/4, and if we wish, we could rewrite this as the decimal 0.25. So the probability that the selected ball will be green is 1/4 or 0.25. Alright, now let's try another example. Here we are randomly selecting one number from the given set, and we want to calculate the probability that the selected number will be either even or prime. To answer this question, we will use the probability formula. The probability that the selected number will be either even or prime will be equal to the total number of outcomes where the selected number is even or prime divided by the total number of possible outcomes. As always, let's begin with the denominator. Here we want to know the total number of possible outcomes. Well, there are 7 numbers in the set, and it's equally possible to select any of these numbers. So there are 7 possible outcomes. Next, we'll tackle the numerator. How many of the 7 possible outcomes are either even or prime? Well, of the 7 outcomes, these 4 are either even or prime. So there are 4 outcomes where the selected number is either even or prime. So the probability is 4/7 that the selected number is either even or prime. Now, I've already mentioned the importance of evaluating the denominator first when tackling probability questions that can be solved using the probability formula. Now let's examine a question that illustrates the utility of this strategy. Here we are randomly selecting 2 people from 5 people, and we want to determine the probability that Amir is selected. To solve this question, we can apply our formula. So the probability that Amir is selected is equal to the total number of outcomes where Amir is one of the selected people, divided by the total number of ways to select 2 people from 5 people. So let's begin with the denominator. In how many ways can we select 2 people from 5 people? Well, since the order of the 2 selected people does not matter, this is a combination question. Now, if you are unfamiliar with combinations, you may wish to review the counting module before proceeding. Okay, we can select 2 people from 5 people in 5 choose 2 ways. Now in most cases, you will find that the denominator is easier to calculate than the numerator is. So when you begin with the easier part, 2 benefits arise. First, in calculating the denominator, we may gain some insight into how to calculate the numerator. Second, if we are unable to calculate the numerator, we may be able to use the information about the denominator to eliminate some answer choices. Here's how. Let's say we don't really know how to calculate the numerator in this question. At this point, we can still evaluate the denominator. Here, 5 choose 2 is equal to 10. So although we're unable to calculate the numerator, we still know that our answer is some fraction with an unknown numerator and a denominator of 10. Since the denominator is 10, we know that the correct answer cannot be 0.15, 0.25, or 0.35. None of these can be the correct answer since there is no integer that, when divided by 10, will result in any of these decimals. So even though we cannot definitively answer the question, we are able to eliminate 3 answer choices before we guess. Now incidentally, the correct answer here is E, and in future lessons we will examine techniques for solving this question. For the time being, however, this question is simply meant to illustrate the importance of calculating the denominator first. Alright, let's summarize. In this lesson, we examined a fundamental formula for determining the probability of an event. This formula is of tremendous value when dealing with scenarios that have countable outcomes.